in last class we have studied about the elastic force transducer. In this lecture we are going to see about the pressure measurement. Myself Dr. Abhas Kanunga, I belongs to Electronics and Communication Department, Kite Group of Institution, Ghaziabad. So, today in this lecture we are going to see about the pressure measurement, what are the different pressures, what are the classification of pressure and what are the different types of devices that are able to measure the different types of pressure. So, in the last class we were discussing about the elastic force transducer. So, we will see about the characteristics of elastic force transducer. There are various characteristics that belongs to the elastic force transducer that we have studied in the last lecture. So, firstly that it converts an input mechanical force such as load, weight, tension, compression or pressure into another physical variable. So, it is a one type of transducer that the force can be measured in terms of displacement or weight, tension, compression or in any other physical variable. Now, in this case into that electrical output signal that can be measured, converted and standardized. So, the force can be measured directly in terms of electric quantity, and as the force applied, the force sensor increases, the electrical signal changes proportionally. So, that there will be the linear relationship between the force and the electric output. So, actually this will satisfy the one of the characteristics of instrumentation, that is linearity. Also the elastic force transducer that allows some materials to return to its original shape after being stretched or compressed. Obviously, when we stretch any rubber or any type of elastic material, then after stretching, after leaving the stretch, that will take their original position or original shape. So, in this lecture basically we are going to see about the pressure measurement. As we know that the pressure is proportional to the force. A pressure is the action of one force against another over a surface. The pressure P of a force F distributed over an area A is defined as the P is equal to F by A. So, as we already told you that pressure is proportional to the force. So, the P is equal to F by A, or we can say that pressure is an application of force by pressing or an urgent demand or force which can cause stress. So, when these two quantities are proportional to each other, pressure is proportional to force. So, by the application of force, when we will press something or an urgent demand or force which can cause the stress. So, that will change the property of the material or that will cause the displacement, because the both the things are the proportional. Now, pressure is a way of measuring how much force is acting over an area. A strong push on a small area creates high pressure, or while a weak push spread out over a large area creates only little pressure. So, obviously, when we applied the force, the displaced area or area will be changed accordingly, and that will obviously depend on the pressure. So, little pressure causes the change in large area, and you can see in the formula that pressure is proportional to the force and inversely proportional to the area. So, it is the basic formula for the pressure. Also, pressure is the amount of force applied perpendicular to the surface of an object per unit area. So, that will be the technical definition according to the formula given. Now, when we talk about the pressure, there are various units of pressure. Obviously, in instrumentation we have seen the various systems, MK system, meter kilogram second, centimeter gram second, and the English system. So, there are lots of unit of pressure. You can see that pressure unit is Newton per meter square, length unit in MKS is meter, CGS is centimeter, in English that will be called as a inch. Like force, in MKS it is Newton, in CG it is dyne, and in English it is pound. Likewise, mass, time and pressure. So, when we talk about the pressure, the very general and basic unit of pressure is Newton per meter square, or that can be called as a 1 Pascal. or that can also be called as a dyne per centimeter square in the CGS system, and also in English system that can be called as a pound per square inch. So, there are the different, these are the different units of the pressure in which the pressure can be measured. Now, we can transform one unit into another according to our application or any numerical. So, here you can see in that diagram the various units of pressure has been given and the conversion is also given. Likewise, I want to convert the 1 Pascal into 1 bar, or 1 Pascal into technical atmosphere, or 1 Pascal into standard atmosphere, or the Pascal into torr, or the Pascal into the pounds per square inch. So, you require a transition from one unit to another. You want to convert Pascal into bar, or the bar into Pascal, or atmospheric pressure into torr, or the pounds per square inch into torr. So, you require different types of abbreviations in that. So, here you can see that 1 Pascal is equal to 1 Newton meter square, that is the very basic unit. Now, Pascal in terms of bar, that will be given by 1 Pascal is equal to 10 raised to power minus 5 bar. Likewise, 1 Pascal is equal to 1.0197 into 10 raised to power minus 5 technical atmosphere. Also, 1 Pascal is equal to standard atmosphere in terms of 9.8692 into 10 raised to power minus 6. Also, 1 Pascal is equal to 7.5 into 10 raised to power minus 3 torr. Likewise, in pounds per square inch. So, here with the help of this table, according to your specific application or according to the numerical given, you can convert any type of unit of pressure into another unit by using this type of conversion. So, basic units of pressure are Pascal, bar, technical atmosphere, standard atmosphere, torr, and pounds per square inch. So, these are the various units of pressure, and according to this table you can convert the desired input into desired form of pressure. Now, there are various types of pressure. So, first we have understood that what is pressure actually, it is proportional to the force. So, according to that there are various mainly the three classification of pressures are there. First is absolute pressure, second one is gauge pressure, and third one is vacuum pressure. So, first we need to see about the absolute pressure. So, the definition of absolute pressure is the pressure is referred to zero absolute pressure and has units of PSI, and absolute pressure can only have a positive values. So, we will see with the help of diagram that what actually the absolute pressure is. Now, likewise, when we talk about the gauge pressure, the pressure is reference to the atmospheric pressure and by convention is measured in the positive direction is known as the gauge pressure. Likewise, just inverse of gauge pressure, when the pressure with respect to the atmospheric pressure and measured into the negative direction, then that will be called as a vacuum pressure. Now, with the help of diagram you can see that, now here you can see that this is the reference pressure and that is our atmospheric pressure, this is our atmospheric pressure. Now, in this diagram you can see that with reference to the atmospheric pressure, if you are measuring the pressure in the upward direction, in the upward direction, then that will be called as a gauge pressure. Likewise, when we talk about the vacuum pressure in reference to the atmospheric pressure, if the pressure is measured in the downward direction, then it will be called as a vacuum pressure. So, when we talk about the vacuum pressure with reference to the atmospheric pressure, we are measuring it into a downward direction, then it will be called as a vacuum pressure, and when it is measured in the upward direction, it can be called as a gauge pressure. And what is absolute pressure? The absolute zero pressure is here, and you can see that this both are, that from gauge pressure to absolute zero, that will also your absolute pressure, and this will also your absolute pressure. So, these are the three classification, main classification of pressure In that we have seen the gauge pressure, what is actually the gauge pressure is, what is actually the vacuum pressure is, and what is actually the absolute pressure is. Okay. So, it is the gauge pressure and the vacuum pressure are just opposite to each other. One is measured in the upward direction with respect to the atmospheric pressure, and one is measured in the downward direction with respect to the atmospheric pressure. So, the pressure which is measured with respect to the atmospheric pressure in downward direction is called as a vacuum pressure, and the other one when it is measured in the upward direction it is called as a gauge pressure. Now, there are various ranges of pressure when we do the numericals, and for the practical applications we need to understand that what are the classification of pressure in terms of their values. So, the low pressure lies between the, that is the less than, the pressure less than 1 bar is below the that comes in the range of low pressure, and when we talk about the medium pressure, the range of medium pressure is the pressure between 1 bar to 7000 bar. That means the pressure lies between 1 bar to 7000 bar is known as the medium pressure, that will be the range of medium pressure, and the pressure that is above 7000 bar is called as a high pressure, or that lies in the category of high pressure. So, that these are the different classification of pressure in terms of their ranges, that what is the range of low pressure, what is the range of medium pressure, and what is the range of high pressure. Now, there are some more important definitions of pressure according to our practical needs or practical application. So, firstly that is the static pressure. So, what actually the static pressure is? When fluid is in equilibrium condition and pressure at any point identical in all the direction and it is independent of its orientation is called as a static pressure. So, when you are having the fluid that will be in the equilibrium, then the pressure at any point, now the pressure in all point is identical in all the direction, because that fluid which you are considering is in the level or is in the equilibrium condition. So, that pressure is called as a static pressure. Now, when we talk about the dynamic pressure, it is just vice versa of static pressure. So, you can see that the technical definition of dynamic pressure is when fluid is in the motion, then pressure is not identical in all the direction, and pressure exerted is depends on the orientation and motion of the fluid. Now, firstly, in case of static pressure, we have considered that fluid is in stable position or in equilibrium condition, but when we talk about the dynamic pressure, there will be motion in the fluid, because the motion in the fluid or the fluid is in the motion, the pressure in all the direction is not identical. So, the orientation will disturb and the motion of the fluid causes the dynamic pressure, and the pressure will be different in all the direction is called as a dynamic pressure. Now, when we talk about the head pressure, now the head pressure is the static pressure produced by the weight of the liquid above the point at which pressure is measured is called as a head pressure. If the liquid is present in the tank, then head pressure on the bottom point is given by P is equal to rho g h. That means, what actually the head pressure is? When the static pressure is produced by the weight of the liquid, that means what, the liquid is in equilibrium condition and static pressure is produced. So, above the point at which pressure is measured is called as the head pressure. You can choose any point and that point is known as the head pressure. The pressure on above that point is known as the head pressure, and if the liquid is present in the tank, then head pressure on the bottom point of the tank is given by the P is equal to rho g h, where it is the very important formula that for differential pressure measurement we will use this formula when we see the pressure measurement. Now, where you can see that rho is the density of liquid in kg per meter cube, g is the gravitational constant that will be in the meter per second square, H is equal to height of the liquid column and P is equal to pressure in the Pascal. Okay. So, here P is equal to rho GH, where P is the head pressure, rho is the density of liquid in kg per meter cube. You need to remember this unit when you are solving, we are going to solve the numericals, and G is equal to gravitational constant, that will be in the meter per second square. H is the height of liquid column and P is the pressure in Pascal or the head pressure, that you can call it more precisely. So, this is the basic formula and these are some important definition about the pressure. Now, there are various pressure measurement methods that are available. In that, first is manometer. What actually the work of manometer is? The pressure due to liquid balance by pressure produced by the column of a liquid of known density. That means, the column or the some type of U tube or inclined tube type arrangement can be used that will cause the pressure due to liquid balance. So, when the pressure is exerted due to the liquid balance, that can be measured by the manometers. Now, there are different types of arrangement to balance that liquid. So, there are different classification of manometers that we will discuss in next slides. Second type of manometer or the second type of pressure measurement device is the weight gauges. So, when we talk about the weight gauges, it is the unknown pressure acting over a known surface area and force produced by it balanced against a known weight. So, the pressure causes by the weight of anything, then it will be called as a weight gauges. Now, we will see different classification of weight gauges and what are the various uses of weight gauges and how it can be used in a pressure measurement, how it can relate to the pressure measurement, because the weight will cause the pressure and the pressure is proportional to the force. So, that will exert a pressure and that can be measured with the help of weight gauges. Third category is mentioned is pressure measurement using elastic elements, because I already told you that elastic elements hold their position after stretching or the pressing. So, the pressure measurement also can be done by elastic elements, that will include the force produced by unknown pressure is balanced by strain or deformation is an elastic element, and that deformation can get its original position when the force has been reduced or force has been finished. So, this is the third type of pressure measurement using elastic elements. So, these are the three basic devices that can be used, and there are different classification in the electrical form or in the mechanical form or in the manometer form. So, we are going to see the classification of pressure measurement method. So, there are various methods of pressure measurement. So, here you can see that the pressure measurement devices, one is two types of mainly methods that we will follow, that first is manometer and the second one is mechanical gauges. Now, in that manometers there are different types of manometers, in that you can measure the head pressure, also you can measure the differential pressure. So, that will be the one advantage of the manometer, that you can measure the differential pressure with the help of manometer, that will be the difference between the two pressure units P1 minus P2, that can be measured by the manometer. So, we will see the classification, there are various classification of manometer, first is simple manometer and second one is differential manometer. So, when we talk about the simple manometer, that will categorize in lots of different classifications. So, piezometer, U-tip type manometer, single column type manometer, that will are the simple manometer, that will not measure the differential pressure. But when we want to measure the differential pressure, we can use U-tube differential manometer or the inverted U-tube differential manometer or inclined type manometer. There are various devices or various manometers are available from which we can measure the differential pressure. So, the manometer is a one of the pressure measurement device that we classify generally into two forms, simple manometer and the differential manometer. Now, the second classification when we talk about is mechanical gauges. Mechanical gauges generally classified into 4 parts. One is diaphragm pressure gauge, Bourdon tube pressure gauge, dead weight pressure gauge, bellows pressure gauge. So, these are generally the elastic pressure transducer, and that also the mechanical type transducer, because there is no electrical work in that includes. So, that will form the last category of our pressure measurement, that is pressure measurement using elastic elements. So, in that we can call this as a mechanical gauges, that can be called as a mechanical gauges. So, these are the elastic pressure transducer, diaphragm gauge, Bourdon pressure gauge, dead weight pressure gauge, bellows pressure gauge, that will we see the next. Now, when we talk about the manometer are basically defined as the device used for the measuring the pressure at point in a fluid by balancing the liquid column by same or another fluid column. So, that is the basic definition. I have already told you about the manometer. Also, when we talk about the advantage of manometer, it is most simplest device of pressure measurement. Also, it is used for the low pressure, that means the pressure below 1 bar can also be measured with the help of manometer. Also, it gives continuous output that will satisfy one of the characteristics of instrumentation. Commonly used fluid in the manometer are the, generally we will use the mercury transformer oil or the carbon tetrachloride or the bromoform and the water. So, these are the liquids that can be used in the manometer. There are various type of liquids selected depending on the pressure and the nature of the fluid where pressure is being measured. Also, that will also depend on the ranges of various pressure. Also, you can see that the U-tube manometer is simplest of the pressure measurement device. Also, we can measure the differential pressure with the help of pressure measurement. We have seen in previous slide, we have seen the formula P is equal to rho g h. Same formula can be applied. We will know the density of liquid, height of the liquid column and the gravitational constant, and through which we can measure the differential pressure or the head pressure by using the U-tube manometer. That is the first simple basic classification of manometer. Now, when we talk about the principle of U-tube manometer, the principle of the manometer is that the pressure to be measured is applied on the one side of the tube, producing a moment of liquid that we will see in the figure. So, one side the pressure to be measured is applied, producing a moment of liquid, and that pressure we need to measure. Also, it can be seen that level of the filling liquid in the leg where the pressure is applied, so that the left leg of the tube has dropped while that in the right hand leg has risen. So, we can see in this diagram, this is the U-tube type manometer. In that diagram, we can see that the pressure is to be measured is applied on the one side, and one side we are having the reference pressure on the atmospheric pressure. Also, we can see that one scale is there. From there, we can know the height of the liquid after applying the pressure. Though startingly the liquid will be something here, and when we applied the pressure, that will move. So, in the left leg the height of the column will reduce, and in the right leg the height of the liquid will be risen, and here the scale is there from which we can measure the height. We will know the gravitational constant, we will know the, also we will know the density of the liquid, which type of liquid you have taken, you know the density of the liquid, that will be in the kg per meter cube. So, if you know all three quantities like rho g h, you can measure the head pressure. So, that is the first basic type of manometer, that is called as a U-tube manometer. There are more different types of manometers that are available, that is inclined type manometers and all other types of manometers. So, it is the most simplest type of manometer that can be measured and that work on the principle P is equal to rho g h. That will be the density, g is the gravitational constant, h is the height of the liquid column that can be measured from here. So, from where we can measure the head pressure, also that can be very advantageous to measure the differential pressure, that we are going to see in the next videos. Thank you.